All right, here's the second part of 7.3, Multivariable Linear Systems. We're going to cover two more examples, and this first one here, or example 5, I should say, is going to be an infinitely many solutions type of problem, okay? So just like before, we're going to go ahead and try to get this system here into row echelon form, and we're going to do that using row operations, okay, here on the left side of the page, okay? Um, it looks like our first equation here is already starting with 1x, so we're going to go ahead and leave equation 1. I'm just going to go ahead and put, I guess I can do e1. E1, no, I'll keep it the same. Equation 1, equation 2, equation 3. So I'm going to start by trying to fix the second equation here, because remember, for a row echelon, you want 1x, 1y, 1z. So we have to get rid of the x's in the second equation. So to do that, I need to get rid of 2x. To get rid of 2x, you do negative 2x, right? So we're going to multiply equation 1 by negative 2, okay? And then we're going to add to equation 2. By the way, these things right here, guys, they're nice to use to keep track of what you did. Okay, so I'm not going to require you to write every single word, but give me something. E times negative 2 plus 2 or something like that. That way I know what you did. All right, so let's go ahead and do that first. So negative 2 times equation 1. So negative 2 times x plus 2y minus 7z, okay, equals negative 4. And we're going to multiply, so it's going to give us negative 2x minus 4y plus 14z equals 8. Okay, so this is what I'm going to add to equation 2. So let's bring over equation 2 and let's add it up. You want to make sure you write the right numbers, because if you do what I did and add a random number here, it's going to mess things up. So the x's are gone. Negative 4y plus 3y is negative y. Plus 15z. 8 and 5 is 13. Okay, so we're going to go ahead, and this is going to be our new equation 2. Okay, and then we're going to replace this one with this one. So now we have x plus 2y minus 7z equals negative 4. There's equation 1. Equation 2 is now this one. Okay, so negative y plus 15z equals 13. And equation 3 we haven't messed with yet. So 3x plus 7y minus 36z equals negative 25. And again, this is our equation 1 that we're looking at now, equation 2, and equation 3. Okay, so here we can see that we're almost done with equation 2, but there's that negative, so we can't have a negative in front. So let's get rid of the negative by multiplying equation 2 by negative 1. And this is where I mentioned the shortcut in the previous video. One shortcut you could do to avoid this extra, row operation. Here on this step, you could have said, well, let's just multiply by negative 1 here and get it done in one go. So that's one thing you could also do. Okay, but I'm showing all the steps, so I don't want people getting confused. Negative 1 times negative y plus 15z is equal to 13, which gives us y minus 15z equals negative 13. So now this is our new equation 2. Okay, so I'm going to do the same thing, replace that over here. X plus 2y minus 7z is equal to negative 4. My new equation for equation 2 is y minus 15z equals negative 13. And equation 3 I have not messed with yet. So let's just rewrite that one. Okay, and again, this is now equation 1. This is now equation 2. And this is equation 3. Okay, so let's go ahead and now that we have our 1x, our 1y, we just have to fix the last one, right? So we always start by getting rid of the first term for our z equation. So to get rid of 3x, we have to add it to negative 3x. So we're going to multiply equation 1 by negative 3, and then we're going to add to equation 3. So multiply this one times negative 3 and add that to this one. So negative 3 times equation 1, okay, which is going to give us negative 3x minus 6y plus 21z equals 12, okay? And let's bring over our equation 3. So 3x plus 7y minus 36z is equal to negative 25. We add these, so my x's are gone. Negative 6y and 7y is positive y. 21 and minus 36 is minus 15z. And then 12 minus 25 is negative 13. So this is now our new equation 3. Okay, so let's go ahead and rewrite this now. You should be seeing something here. Equation 1 is x plus 2y minus 7z is equal to negative 4. Equation 2 is right here. Y minus 15z is equal to negative 13. And equation 3, we just found that one, is the exact same thing. So we have y minus 15z equals negative 13. Uh-oh, what does that mean? Okay, so when this happens, it's going to mean that you're going to have infinite solutions. Okay, so what we do is, at this point is we try to find an expression, okay, or expressions, I should say, that will give us particular solutions if we were to input certain values, okay? So here's how we do this. We're going to work with these two equations since these are the same, okay? So since the same, this means infinite solutions. But we're not quite done yet. We have to figure out some expressions that would give us particular solutions. So for example, if z is equal to 1, what is that? What are x and y going to be equal to? Okay, so excuse me. So to do that, we're going to let z equal to some random number a, okay, that means such that a is a real number. So a is any real number, okay? So this is going to be kind of a little side note here. So with that in mind, I'm going to solve this for y. So first, solve for y. So y minus 15z equals negative 13, just because it makes it easier to plug stuff in. Okay, we would add 15z to both sides. So y is going to be equal to 15z minus 13. Okay, and we're going to go ahead and plug this one into the top equation to get everything in terms of z, since we know that z is going to be the one that decides what is what. Okay, we want to write everything in terms of z. So this is what y is equal to. Okay, let's go ahead and second, we're going to plug into first equation. So we're still kind of doing what we did in the other one, but instead of plugging in numbers, we're plugging in expressions now, okay? So now we have x plus 2y minus, I keep putting z there, minus 7z is equal to negative 4. I'm going to plug in where the y is. I'm going to plug in all this. So x plus 2 times all of this, 15z minus 13 minus 7z is equal to negative 4, okay, which gives us x plus, distribute, so that's 30z minus 26 minus 7z equals negative 4. Combine like terms, so that gives me x plus 23z minus 26 equals negative 4. I'm going to run out of space here. Move the 26, so plus 26 to both sides. Let me work up here because I need this space right here. That's going to give me x plus 23z. Negative 4 and 26 is negative 22. Okay, let's move the z over, which gives us x is equal to negative 23z minus 22. All right, so what this does is it gives us some expressions in terms of z, because remember z is where we kind of lost, where we found that infinite solution. And these are going to represent where we get our expressions from for the system. Okay, so here's how we're going to word this. To find, and this is a little bit of college verbiage, a particular solution, okay, let z equal a, so just like what I wrote up here, okay, such that a is a real number, and let's see, how do I want to put this? We'll just put the solution. So for x, we're going, let me try to, I'm sorry guys, I'm trying to get this all on the screen here. Let me zoom out a little bit. Okay, so x, y, and z, okay, that's usually our solution, right, is equal to, well, x is going to be equal to this guy right here, negative 23, but instead of z, I'm going to use a, negative 23a minus 22. Instead of y, I'm going to use this one, 15a minus 13. And for z, I'm going to just use a. And this will give us a particular solution. So in other words, if I make z equal to any number, and any number is represented by a, this would work. So if z equals 1, I plug in a 1 here, and I get an x, a y, and a z. And that's it. Okay, this is an infinite solution. So make sure you do have that. This one has infinite solutions. But if you're looking for a particular solution, it's going to be based off of this right here. Okay? All right, so let's look at the last example, and then we are done. I don't think this one will take that long because it's actually shorter than the other ones. So we have, for example, 6, a non-square system. A non-square system is basically one where the number of equations is not equal to the number of variables, meaning it cannot have a unique solution. So far, the only one that had a unique solution was that first one, the one with the one solution, okay? To obtain a unique solution from something that has no solution is impossible. To obtain a unique solution from something that has infinite solution is possible if you do what we just did, where you set something equal to a random number a or b or whatever from the real. So if you want just that one specific solution, okay? So this one cannot have a unique solution, and we're going to see why in just a bit. Okay, so let's go ahead and start off by, let's see, we have the first equation already done, so we don't have to worry about moving anything for the top. We're going to get rid of our 2x, so we're going to do the same thing we've been doing. We're going to get rid of 2x by multiplying equation 1. So this will be our 1, this will be 2. So multiply equation 1 by, let's see, by negative 2. Because if I do this times negative 2, it'll get rid of the 2x there. And add to equation 2. Okay, so negative 2 times x minus 2y plus z is equal to 2. Distribute gives me negative 2x plus 4y minus 2z is equal to negative 4. Okay, and I'm going to bring over this equation. So 2x minus y minus z is equal to 1. These guys are gone. 4y minus y is 3y. Negative 2z minus z is negative 3z is equal to negative 4 and 1 is 3. Okay, so now this becomes our new equation 2. So let's go ahead and rewrite that. So I have x minus 2y plus z is equal to 2. And this is now equation 2. So 3y minus 3z is equal to 3. Okay. And then this is now equation 1. This is equation 2. I still have a 3 in the way, so I'm going to do this because I'm out of space there. I'm going to multiply times a third. So multiply equation 2 by 1 over 3. And what that's going to do is it's going to get rid of all those 3's for me. 3y minus 3z equals 3. So 1/3 times 3y is just y. 1/3 times negative 3z is just z. 1/3 times 3 is just 1. So now this is my new equation 2. Okay, so let's go ahead and move that over. Now I'm going to have x minus 2y plus z equals 2. If you hear all those little rings, it's just my computer with notifications, so sorry about that. And then I'm going to bring this guy over. So y minus z equals 1. Okay, and this is equation 1, this is equation 2. And you can see here that technically we're kind of done, right? Because the x has a 1, the y has a 1, and well, there's no third equation for z, okay? So what do we do, all right? Well, since we don't have an equation for z, that means we're going to have to write these equations in terms of z so we can figure out, at least particular solutions. So if we can find one. So let's see. We're going to solve for, well, I guess solve for y, you should say. Solve for y in terms of z, since we're missing that one. So let's do that. So y minus z equals 1. We're going to add z to both sides, which gives us y equals z plus 1. Okay, so how is that going to help us? Now, just like the problem we had before, okay, we can plug this one into the other one to get that one in terms of z as well. So first, I don't want to put a 1. We'll say first, second. There, you could say step 1, step 2, if you want. We're going to plug into equation 1. So we're going to have x minus 2y plus z equals 2. X minus 2 times our y is equal to all this. So z plus 1 plus z equals 2, like this, okay? Then I distribute, so I get x minus 2z minus 2 plus z is equal to 2. Combine like terms, which gives us x minus z minus 2 equals 2. Okay, and I'm going to add the 2 to both sides. I'm trying to go kind of small because I'm almost out of space here. So x minus z is equal to 4. Move the z over. So x is equal to z plus 4 or 4 plus z, however you want to think about it. And it works similar to the one we just did, okay? So to obtain a solution, we can do what we did in the previous example where we use these as let a z equal to a, and then write out expressions that are going to give us that solution. All right, so we're going to go ahead and do that here in the bottom where we had just like before, okay, we let z equal to a, okay, then you would have this following solutions. Remember x, y, z is what we're trying to get, such that a is a real number. Then our solution would look like the following: a plus 4, a plus 1, and just a. Okay, and that's basically it. So like for this one, you can kind of tell just from the way beginning, it's going to be one of those that's not going to have a unique solution. It's going to have infinite ones like the ones before. And these are all going to be in the form of ordered triplets that look like this, okay? So that's it, guys. That's it for this video. I know these are kind of long, so if you have any questions, let me know. Make sure you do double check your work. Hopefully I didn't make any mistakes. As far as the one solution, no solution, those are pretty accurate. They might be off by a digit or two if we miscalculated somewhere. So feel free to check. Let me know if you catch anything. Let me know if you have any questions.